let's look at the problem over here. More appliances are plugged into an outlet. You've probably all been told that you shouldn't plug too many things into one outlet. And the reason that you shouldn't do that is that if you plug a lot of things into one electrical wall outlet, you're going to draw more current in those wires. And with all those electrons moving through the wire is going to get very hot. The wire can actually get so hot that it will melt the plastic coating, melt the insulator, and cause a fire. This turns out to be a very serious problem. If this happens in your house, the electrical wires in your house are inside the wall. If you run too much current through those wires and melt the insulator, it can start a fire. And it's very dangerous because by the time you realize, remember the fire is starting inside your wall, by the time you realize what has happened, it's usually too late. The fire has spread throughout the wall and will burst through, and that can be a very bad situation. So it's often the fire is often hidden, and by the time the person realizes that something's wrong, it's too late, and you've got a major house fire on your hands. There's two solutions to that problem. One solution is to use fuses, and a lot of electrical devices will have a fuse in them, and it can look like this, or it can be a piece of plastic, but what all of them have is a thin wire inside. And if you run too much electricity through that thin wire inside that glass tube, well, you guessed it, that wire will burn up, and it will break the electrical circuit. It will stop the electrons from going through. So this would be in line in the circuit, and if you run too much electric current through this, that thin wire in the middle will burn, and it will shut off the electricity and prevent the fire. So a lot of things, you may have power tools that have fuses in them. Your car, when you guys get a car, some of you may already have a car, but there's a fuse box in the dashboard. It's usually near your left knee. And then there's also another fuse box under the hood, and it's usually near the windshield, near the firewall of the car. But if you open up that fuse box, what you'll see are these little plastic devices in there. They kind of look like teeth, actually. But if you look at them closely inside the plastic, you'll see a thin wire, and the fuses are typically labeled 5 amp, 10 amp, 15 amp, 20 amp, and the higher the amperage, the thicker that wire. But it's the same idea. When that wire burns up, it shuts off the electricity and prevents a fire. Okay, the other solution to this problem of having too much current go through a wire is what's called a circuit breaker. And you've probably all seen this in your house or in buildings. It's a metal gray panel, and you open the door, and there's all these black circuit breakers stacked on top of each other, and they all have a switch. And if you run too much current through each one of these switches is a circuit. So this one might be the air conditioner for your house. This one might be the water heater. This one might be the heater. This one might be the electric range or the electric dryer. And then the smaller switches, that might be the lights for your living room, the lights for the bathroom, the lights for the garage, etc. But if you run too much electricity through any of these circuits, rather than burning up like a fuse, the way circuit breakers operate is on a thermal overload. If it gets too hot, that switch right there will flip, and it cuts off the electricity. So when you blow a circuit breaker in the house, when it gets too hot, that switch will move. And if you let it cool down for a few minutes and unplug whatever you had plugged in that was too much current, you can flip the switch back to the regular position, and it will restore the electric power. Okay? So a circuit breaker is nice. A fuse, when you burn out a fuse, it's no good anymore. You have to throw it away and put in a new fuse because it's burned up. And that's what your car has. Your car, all of you will probably, all of you are probably going to own a car, and sooner or later you're going to have fuses burn out in your car. So it would help you a lot if you learn how to replace them. The advantage of a circuit breaker is that it is reusable. If you run too much electricity through a circuit and it trips the circuit breaker, you unplug whatever it is that was causing the problem, let it cool down, and then you can flip the switch back and your electricity will still work. Okay? AC/DC. It's a band you may have heard of, but really what we're talking about here is alternating current and direct current. Alternating current is where the current, the flow of electricity in the wires in your house goes back and forth. It goes in both directions. That's why we call it alternating current. And we don't really realize this, but that causes, like, for example, when a light is on in a room, that light is actually going on and off repeatedly. It's turning on and off repeatedly, but it does it at so fast a rate that we don't notice it. It looks to us like the light is on all the time. But it's actually shutting on and off very rapidly because of the alternating current. All households have alternating current. So anything that you plug into the wall in your house is operating on AC, or alternating current. Direct current, on the other hand, is where the electric charge only flows in one direction. It doesn't go back and forth. It just goes from, for an example, in the battery, it goes from the negative terminal to the positive terminal. Now, where do you find direct current systems in everyday life? One of the most important examples would be cars. An automobile, a modern automobile, is a 12-volt electric system. There's a 12-volt battery under the hood that's charged by an alternator that runs off the engine. But all the electrical things in your car, the power windows, the power door locks, the radio, the headlights, the tail lights, anything in the car that operates on electricity is operating on a 12-volt direct current system. Also, too, your cell phone, your computer, power tools that are battery operated, like a cordless drill, all of those things also operate on direct current. Okay? A computer is, you might think that, well, computer, your laptop computer, you have to plug it into the wall. And that is true. Your computer is charged from an alternating current source. But you've probably noticed when you charge your computer, you plug the cord into the wall, and then there's a little box, and then there's another thinner cord that goes to your computer. But what that box does in the charger, what that does is convert the alternating current to direct current that your computer operates on. So make sure you watch this video. It does a really good job of explaining how alternating current works and how it works in your house, and why you can't see the lights flashing on and off and so forth. So that's a really good video that explains the difference between alternating current and direct current. And you can also watch, if you wanted to do find out some additional information. Historically, Thomas Edison advocated direct current systems. Nikola Tesla advocated alternating current systems. And you can see who won that battle. Today, our households, all run on alternating current. Alternating current is far more common than direct current systems. Direct current systems are only found, like we said, in cars and handheld electronics, things like that. Interestingly, though, even though Tesla's system was used, Tesla himself died penniless, and Edison died quite a wealthy man. But if you go on YouTube and look up history, there's a lot of really good History Channel videos about the conflict between Tesla and Edison that you might want to look at. Okay, next slide. Okay, electrical energy can be easily converted to other forms of energy. Here you have a little diagram of a power plant, and the electric energy comes out of the power plant and it's converted into radiant energy or light. But you know, obviously, if you think about it for a minute, electricity can be converted into all kinds of energy. I'm sitting in a room now making this video. I've got lights on in the room, so electricity is being converted into radiant energy. I'm making a video on this computer that's going to have sound, so the electricity can be converted into sound energy. There's a ceiling fan in the room that operates on electricity. So there the electricity is converted into kinetic energy. This fan rotates. The room is heated by electricity. The air conditioner for the house, which removes the heat to outside of the house, operates on electricity. So electricity can be converted into just about any type of energy we could think of. Okay. Now, electrical power is the rate at which electrical energy is converted into other forms of energy. And the way you calculate power, it's a very simple formula. Power equals the current times the voltage, and the power is measured in watts. And what you can do to see this, if you look around your house, anything that's electrical, a hair dryer, a guitar amplifier, a lamp, a computer. Computers, it's kind of hard to read the label because it's usually really tiny print. You know, anything in the kitchen, a toaster, or a microwave oven. If you look at any power tools like a drill, would be very easy to read. If you look at it, it'll give the power of that device in watts, and it may also give the current. Okay, and then you know that your house is 110 volts when you plug something in. So that's how you figure out the electrical power of the device. And for a lot of devices, you can look right on it. You don't have to figure out the power. It's got a label on it. You know the voltage for your house, you know the current, and it will tell you the power. Oops, back a slide. Then down here at the bottom, we can also figure out how much energy is consumed and what our electric bill will be because we're charged by the kilowatt hour. And the formula for that is the electrical energy consumed equals the power times the time that the power was delivered. Okay? And the unit is kilowatt hours, and 1 kilowatt hour equals 3.6 million joules.